So hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 13 of the May Day Leetcode challenge and we have again a video question for us. Let us see what the question is. Okay. So we are given four parameters here. As you can see in this example, we are given four parameters. Let us try to understand what they are. Okay. So we are given these four parameters which are integers actually, and we are asked to construct a string, okay, by starting with an empty string. And see, the idea here is we are given empty string initially, and we have to do the following operations to get a good string. Okay, what is the definition of good string? We'll see later. But let us see what are those operations. Okay, first we have to append the character 0 times, and this is one way, or we have to append the character 1 time. See, the 1 0 we are seeing here, it's a variable name. Okay, the 1 0. See, for example, in this case 0 is 1. Okay, in this case 0 is 1. In this case 1 is 2. So these are variable names. Okay, don't doubt them to be 0 or 1. Okay, see, these are variable names. Okay, so these are 0 represents the number of times this character will be added to the string. Okay, and this represents the number of times this particular character will be added to the string. Okay, that is the basic idea here. I will show you with examples also. And let us see, these are operations. Okay, these are some of the operations. Now let us understand what is the definition of a good string. Okay, a good string is a string constructed by the above process having a length c. These are the operations, but the definition of a good string is that they should be between, the length should be between low and high. Okay, both are inclusive. Okay, for example, if the low and high, for example, this low is 2 and high is 3, that means both strings of length 2 and length 3 are like eligible for being a good string. Okay, that is the basic idea. But only thing is, we should follow these rules. Okay, 0 should be added only this many number of times at a time, and similarly 1 can be added only this many number of times at a time. Okay, let us see the first example. In this case, low and high are same. That means there is only one option for the string length. It has to be 3. 0 is given value 1, 1 is given value 1. Okay, what it means is we can add 0 at a time 1, and similarly 1 we can add at a time 1. So what it means is, see, the lengths are fixed. Okay, that means all possible combinations of three character strings where 0 and 1 can be interchangeable. That means all binary strings starting from 0 to 1 okay, are good examples. Okay, are good strings in this example. Okay, then see, the major example is something like this. I will trace and show you how it works. But before that, I hope you are clear with the question. See, we are given an empty string and we are going to append zeros and ones to it. Okay, zeros can be appended only these many number of times at a time. For example, see, in this case 1 is 2. Okay, in this case 1, that means the two ones have to be together always. There cannot be a single one any time. Okay, see, two ones have to be together always in all valid strings. Okay, but this 0 is 1, that means a single 0 is feasible. Okay, here 2 are there, but a single is also feasible. That is the basic idea. At a time only these things should be there. Okay, that is the basic idea. And let me tell you how I'm going to solve this question. Then I will trace the example. Okay, I am going to declare an array dp. Okay, this I am going to solve in the dynamic programming way. Okay, let us first define what is dp of I. Okay, dp of I is be the number of good strings with length I. Okay, number of good strings with length I. Because see, one thing is we have to be very careful is we have to return all possible good strings between these particular lengths. Okay, between low and high lengths, both are inclusive. Okay, for example, here lowest 2 and high 3, that means we have to return both things where 2 is also feasible, 3 is also feasible. That is the basic idea here. Okay, so we have to try for all possible strings. Okay, within these lengths. So dpy is the number of good strings with length I. Okay, so let us now trace this example. Okay, let's see, one thing you have to understand is dp of 0. That means a good string of length is 0. How it is possible? It can be empty string only, then it is possible. Okay, so dp of 0 will be always 1. Okay, empty string is the only good string with length 0. Okay, now let me trace and show you for the example number 2. One thing is sure, the first will be 1. Okay, dp of 0 is going to be 1 as we saw here. Okay, now let me trace for the second thing. Okay, I want dp of 1. That means number of strings with length 1. Okay, how it is possible? See, I'm going to trace for the second example. Okay, see, there is only one case here. Okay, see, I can add 1. See, whenever I am adding a 1, it has to be a double thing. Okay, so only two ones can be added together, but I need a string of length 1. Okay, dp of 1 means all good string of length 1. So this, the only option here is to take this. Okay, so there is only one way. Okay, in which this can be done, or you can say, yeah, there's only one way to do this because I can take only this. Okay. Now comes dp of 2. Okay. dp of 2. How to find dp of 2? See, there are two ways to do it. Either thing is we can in the dp of 1. Okay. In the dp of 1, we can add this thing. Okay. In the dp of, see, that idea here is we have to construct the answer for the dp of I from dp of I minus 1 and dp of I minus 2 in this case. Okay. How to do that? See, I am talking about dp of 2. dp of 2 means See, in DP of 1, I can add a single character and make DP of 2. Okay, I can add this character in all DP of 1 strings and make this character. So, in one way to do is this, just copy this variable. Okay, let's copy this variable here. Okay, this is the one way. The other way to do this is, yeah, 1 plus. The other way to do this is, in a DP of 0, you can add two things to get DP of 2. Okay, 0 plus 2 is 2, right? So in DP of 0, you can add this particular string, okay, and get the DP of 2. So we will add this again, okay. So it becomes 1 plus 1, okay. 1 plus 1 is equal to 2. Now we'll go for DP of 3. How to get DP of 3? See, we can get DP of 3 from DP of 2, right? In the DP of 2 strings, like whichever strings are coming in the category of DP of 2, we can add this particular thing once, okay? We can add a 0 between them, 0 after them, all string ending with 0, that is, okay? And we can get DP of 3. So I will just take this answer, okay? This will be my 2 is. These are strings which of length 3 and end with 0, okay? The other way is, we see, because I'm trying to find DP of 3, right? In DP of 3, what I can do is I can take DP of 1 and add these things behind them. So I will add 1, 1, 1. See, these two ones behind all strings which are eligible in DP of 1. Okay. Thus I will get DP of 3. So what is DP of 1? This is the DP of 1. Okay. 2 plus 1. Okay. 2 plus 1 which is equal to 3. So what I'm getting 1, 1. Okay. 1, 1. I will just rub these things now. 2 and 3. Fine. Now how to find the answer? They have clearly given here. See, good thing is considered to be above the, okay, we have to follow above process, and the length between, see, length between low and high. So what is low and high in this case? Low and high is in this case is 2 and 3. So we have to add the index 2 and index 3. 2 plus 3, which is 5. So that is the answer here. So the idea here is we are going to see, we will start from DP of 0. That means you will start, see, DP of 0 is 1, right? So we will start from DP of 1. That is, we will try to find all possible strings of a particular length I, okay? And from that, we will try to find what is DP of I plus 1 and DP of I plus 2. Okay, that is the idea here. So we are using this subproblem approach. We are making a problem, we are dividing a problem into subproblems. We are going to use the results of the previously solved subproblems to get the current result. That is the basic idea. But like, what should be the length of the DP array? One thing is very clear. The length, see, please see the definition of DP once, is the length of good string or length I. Okay, what are the, see, we have to go for a maximum of high. That is the number. We see high is 3 in this, right? So this is the number where we want the answer to end. Okay, so this is the maximum number length of string which we want. Okay, so the length should be between low and high. So but to get low, we should need the previous length also, right? For example, low is 5, means we need length 4, 3, 2, 1, 0 also, right? So that is not controllable, but the length, the highest length is controllable. Okay, so the length of the DP array should be high. Okay, high means it's a number here. It depends on, it's a variable which depends on number, right? That is the basic idea here. Let us see how this program works. What we're doing is we are initializing a DP array first of all. See, see, if we have to go by index, okay, I want the last index to be high. So what I should do, I have to write here high plus 1. Okay, for example, if you want the last index to be 5, you have to make array of length 6. Okay, that's 5 plus 1, because it should start from 0, right? So that is the basic idea involved here. I'm initializing everything with 0. Okay, so if you print this array, it will have only 0 values. Okay, as discussed here, the first element should be 1, because for empty string, for it to be good, there is only one string like that possible. Okay, that is a single empty string. Okay, so DP of 0 is 1. I'm declaring a mod. See, because they have given here, we have to return the answer modulo 10 power 9 plus 7. That is what I'm doing. In Python, the stars will lead to exponential power. Okay, that's 10 power 9. If you do 2 stars, it means like raised to the power of. Okay, that is the basic idea. See, DP of 0 is already given to us. We will start the calculation from DP of 1, and we'll go to, see, here high plus 1 is written why. See, in Python, whenever we use the range function, the whatever is the second parameter, it will go 1 less than that. Okay, so if I write high plus 1, it will go till high. That is the basic idea. That's why I'm writing high plus 1 here. Okay, so and is the parameter. Okay, it will range from 1 to high. Okay, so first, see, here in this case 0 was 1. Okay, so for getting index I have to see, suppose I have, see, DP of 1 given to me. Okay, if I want to find DP of 2, what I have to do is, see, I have to add one character to it. Okay, DP of 1 depends on the number of things, right? In those things I have to add just one character to it to get DP of 2. Okay, so how that one is coming, because of this. So it depends on the length of 0 and 1. Okay, so we are just, see, going to a DP of end. For example, in case of 0, that means when we want string to end with 0, what we are doing is, see, end minus 0 we are doing. This is the index. See, it will depend on the DP index of a subproblem, right? So we are going to see this will, for example, 0 is, let us say, and is 5 and 0 is 2. Okay, 5 minus 2 is 3. So behind all things which are coming under DP of 3, we are going to add two zeros. Okay, and we are going to DP of 5. That is the idea how we are doing that. Okay, and but see, this could lead to a negative number as well in the initial indexes. That's why we are checking this. Okay, that is the idea. This is for 0 and this is for 1. The exact same thing, and for the 0 and this is for the 1. Okay, we are doing DP of n minus 1 because see, this is a 1. See, try to answer things very carefully. See, I'm again repeating this example. Suppose you want to calculate for DP of 5. Okay, but in this case, let us say the 1 is 2. Okay, so what I will do is 5 minus 2 is 3, right? In the DP of 3, it will have some number, right? This number will depend some things. Okay, those things I will add two ones behind them. Okay, to get DP of 5. Okay, so the DP of 5 will depend, like the DP of 5 will depend some things. Okay, ending with 1 and ending with 0. There are two parts for it. Okay, so the one ending with one part is coming from this. Okay, DP of 3, and similarly this for the ones ending with 0. Okay, that is the basic idea. Finally, I will do a modulo in this itself. Okay, but remember, finally we have to return a sum of these things. Okay, and for the finally we will count a sum also, and finally we'll do again a modulo. See, where we are counting sum, we're starting from 0 and ending with high. Okay, see why I'm writing high plus 1. As I said, always the second index we have to take 1 plus what we want. Okay, because if we take 1 high plus 1, that means it will take from index low to index high. That is the basic idea how it's being done. And finally we're again doing a modulo. Okay, so let me quickly print and show you for the second example how the DP array is looking. Okay, let me go to the second example, and yeah, this is the one. Okay, 1123. As you can see here, I am printing the DB after it's calculated, and this is what we calculated. As you can see, both are matching. Okay, it's clearing out test cases. It's nearly 70 to 80% faster compared to our partial solutions. Okay, so here I have given the example also. See, DP of 5 in the example what is being calculated is C. See why, it's just example, we don't need 5 here because high is ending with 3, but just example. Okay, see, 0 is once. Okay, so that means all DP of 4 strings we will add 1 to get DP of 5. Okay, so that's why DP of 5 is coming, because see, 5 minus 1 is 4, so this is where DP of 4 is coming. Okay, and because 1 is 2, so what we'll do is 5 minus 2, which is 3. Okay, so behind all DP 3 strings we'll add two ones to get DP of 5. So DP of 5 will come from two parameters, DP of 4 and DP of 3. Okay, what we'll do is behind all DP 4 strings we'll add a 0, and behind all DP 3 strings we'll add two ones to get DP of 5. Okay, so this is the basic idea. And one thing you have to remember is, see, whenever doing modulo here, for the individual ones, you have to do the model for the sum also. Okay, this is like a standard definition how it is being done. If you are not doing it, your answer will be getting exceeded, right? So yeah, friend, that was all for today. If you went out, please do comment below. And yeah, coming to space and time objective of it, yeah, because see, we are going to take array which will start from 0 till high. Okay, so the time velocity will be O of h high. Okay, O of high, and the because CPR is we are creating new array, right? So space component also will be similar. So yeah, friends, that was all for today. If you have any doubts, please do comment below. And if you have a better approach to this or any other approach, like a different approach, a totally different approach, because I'm following dynamic programming here. If you have any different approach, please do comment below. We can discuss it further. This question are really nice because see, if you try to do it any other way, you may not get your answer accepted because this time limit exceeded error will come, right? So yeah, that was all for today. Let's meet tomorrow. Thanks a lot.